Thanks for being accommodating with us for changing the date by like a month and a half. The reason we changed the date is because I forgot that we're moving into a new building, and and so somebody emailed me and said, hey, we're not going to have this meeting space at the date you picked. So that's what we're doing now. But it's a good day for the meetup ultimately because the new space we're moving into, which is only 2 blocks away, is going to have a meeting space that's going to be like 3 times as large with much better sound system and so on. So we should be able to have some really exceptional events there. We have, I want to mention we have a couple of meetups coming up while we're still in the space yet. We have, so if you go to the meetup page, just the data mining, you can sign up for those, or at least put your name on the wait list. And if you really want to come, obviously, there's, you can just come. Let's see what else. Just for the agenda, just so everybody knows, for those of you new, this will go until the event officially goes until 8:30, but our speakers will talk until they are ready to end things. Should probably be around 8, and then we'll probably be around a little while to meet one-on-one if you guys want to afterwards. There's always some people left when the event sort of closes and they want to continue networking. So I would mention that there are some really good bars for networking down in Mina Street, which is the alley right next to Trulia, right off of New Montgomery. There's John Collins, for example, is a really great bar just to hang out with people. So you can do that. So our speakers tonight are from KNIME. We have Rosaria, Cathy, and Jay. And I will let them introduce themselves much better than that.
Okay. Can you hear me? Everything is working. I'm not very used to this kind of thing. Okay. So if you don't hear me, tell me. If you have questions, stop me. Whatever. So I'm going to start quickly, and I'm going to give you try to have everybody with the tool installed, so that we can start with the hands-on part. And I'm going to show you how the tool works very quickly. Then I'm going to pass the word to Cathy, and she's going to show you how the text processing extension works. KNIME is actually a data mining tool. So what we are going to do today, what we are going to see today is only the text processing part. But there is so it's used in general more for data mining than for text processing. So just to explain to that, we are going to see only one small part of the program. So here there is my email. So if you, I'm going to walk you. I think you have downloaded 8 or 9 workflows. So I'm going to walk only from the workflow number 1 to the workflow number 4. So after that, you can have a look at the other workflows later, quietly at home, no problem. And if you have problems, you can always send me an email. If this one is on, you can always send me an email, or one of us, about problems that you might have with the text processing part. So here there are 3 email addresses. One is mine, one is Cathy, and one is Kilian. Kilian is actually the author of the text mining processing package. So I think he's the most qualified if you want to implement stuff or include the source of the programs in your program. Okay, so I was around before and I asked if you already have installed the tool, so I assume that everybody has. If you haven't installed the tool yet, here there are some USB sticks with the whole downloadable part, so that you don't have to connect to the network, and it's a bit faster. So if you need it, they are here, so you can install it on your machine. Okay. So as part of the downloadables that you have on these USB sticks, there are also the workflows that I'm going to use today. That's a zip file. So copy the executable, so the package for your operating system, and then also copy the zip file with the workflows. Okay. So how many people? Okay. So I continue. I hope it's okay. So text processing can take a lot of memory. Today we are not going to work with a huge data set because it's just a tutorial, but it can be, very memory expensive. So if you are going to try to work on a lot of data, then maybe you might want to change the memory setting in the KNIME.ini file. So you find the KNIME.ini file in the directory, in the folder where you have installed KNIME. You open it, and then you change this line here to, I put here 3 gigabytes, but of course, depending on what your machine can handle, you can write whatever you want. The default, I think it's only 1 gigabyte, because you have to be sure that KNIME is working on all possible machines, and so you somehow make it uniform to the lowest possible available memory set. So those are a few resources if you want to learn more, because today I'm not going to cover everything for sure. So there is the Learning Hub up here. That's from the KNIME website. The Learning Hub has a list of resources. They are divided by topic. So if you want to know something more about data mining, there are a bunch of books that you can buy, or a bunch of videos that you can watch on YouTube, or I don't know, white papers that you can read, stuff like that. If you want to know more about loops, same thing, and so on. So you go by topic, and then you can choose the one that interests you the most. Of course, there is also the text processing part. There are some use cases and white papers. If you want to read something special, some particular topic, then of course there is the forum. The forum is one of the biggest resources of KNIME. So you can just connect to the forum and search. Probably somebody has already asked the question that you want to know. There is a person that I know that he said that using Google and the KNIME forum, he could learn everything without even opening a book. I don't know if it's recommendable, but that's what he did. Then of course there is documentation. There is the labs that contains the more advanced nodes. Then there is the community, where KNIME is open source. So one of the nice things of having an open source tool is that there is a lot of community, and somebody has already developed something that you probably need. So if it's not available already in KNIME, somebody's developing it. There is the blog, and then last one, there is the KNIME TV channel on YouTube. There are I think 70 videos on how to do a number of things, and one of these videos is the text mining webinar that was done 1 year ago, and you can, so you just type text mining webinar KNIME on YouTube, and it should come out with the full video of the webinar. And then of course we are on Twitter. And for today, so KNIME has also a few books. So some of these books are, you can buy them. For today you have a free code, and you can download the KNIME Beginner Slack, using this free code. So if you want to take note of the code, and then you want to later buy the book for free. Okay? Have you all? I'm going to put this page again, so if you haven't taken the code, the free code yet, you can take it later. Okay. So I'm going to quickly talk about the text processing steps. Okay. So for the text processing step, they're more or less always the same, whatever tool you use. First of all, you need to import the data, and then there are a number of functions or nodes or whatever to be able to import different data types. So you can import PDF, you can import a Word document, you can import HTML, you can import XML, you can import flat files, whatever. After you have imported your data, then the second step for the text mining, how many of you are already familiar with text processing? So not that many. Okay, so the second step for the text mining, for the text processing, is to provide some enrichment. Enrichment means mainly tagging. So you have to, you have a text with words, and you can say what each word mean in a particular task, for a particular task or for a particular context. For example, if you want to do sentiment analysis, right? Each word carries a particular meaning, positive or negative. So then you are supposed to tag each word with some negative or positive connotation. If you want to find out, let's say, the name of the people in a particular text, then you might want to discover the names of the people and then tag them and say that's a name of a person, and so on. So there are many, each word can carry many tags depending on what you want to associate with a particular word in the text. That's the part of the enrichment. And this one requires usually a dictionary. The dictionary is usually made by linguists. You can make your own, of course, if you are, if you know what you're doing. But there are also a lot of resources already available on the internet. After tagging, then there is the whole pre-processing part, and this includes filtering. So all the words that you don't want to have because they are not important, they are just noise, and so you don't want to have all the words that the numbers, they are not, you just don't want to have, they don't carry any meaning for your particular task. Another particular thing that you might want to do at this level is the stemming. So if you have, for example, the word feeding, for example, to feed or feeding or I fed, those are all different forms of the same concept. So if you want to produce, if you want to use this word, the meaning that this word carries, then you might want to reduce all these different shapes to the only original form. So the stemming, that's what it does. It takes the stem of the word, removing the particular shape, the conjugation, the declination, if it's a language with declinations, and so on. Okay, once you have done all this pre-processing part, then you need to transform your text into a vector of numbers. And once you have the vector of numbers, you can apply the traditional data mining techniques, because once it's numbers, it's numbers. And then you can, you can just perform classification, clustering, using a decision tree, using whatever you want to use, you usually use with data. Okay. So I'm going to give you a quick, like 5 minutes demo of how the software works, because otherwise we are not going to go much further with the, with the text processing part. So okay. So if you have installed it, you just start the application wherever it is that you have installed it. If you have on your desktop or wherever it is. So KNIME uses a workspace. Many of you are R experts already? R? Who programs in R already? Okay. So the workspace concept is clear. So it's where all your work is held. So you're going to have all the workflows that we developed today, for example, are going to be in the workspace that I choose now. A workspace is just a folder. So you choose a folder wherever it is, it can be anywhere. And, sorry?
Does KNIME use R behind the scenes?
No, KNIME has nodes. KNIME is written in Eclipse, in Java. So if you download the source code, you see it because you download also the full Eclipse environment. It has some nodes that interact with R. So you can call R and R scripts and import them into KNIME, execute them inside KNIME. Also, the nodes that have R, call R, they are kind of an R editor. So you have syntax highlighting for R, you have a debugging for R, so these kind of utilities, I have to say, I find them very useful. I'm not an R expert much, but yeah, I find it very useful when I use R. Okay, so let's use this folder for our workspace, and yeah. Okay, so here I have a few things that I have not installed, but that's okay. So you start with this welcome to KNIME page. There are a few links that you might want to use if it's the first time, just to get some orientation. And then, okay, so let's remove this welcome page. Okay, so and then you can see that this one is the KNIME workbench. Here you have the KNIME Explorer that contains all the workflows that you have produced so far. So local is your local workspace, and here there is the list of servers if you are connected to any of the KNIME servers. These examples I'm going to show you later what it is. So for example, for today I have imported all my workflows in here. So you can see here you have the full list of workflows. This is the list of the nodes that are available. So So here those are all the categories, and you can see that here there is a KNIME labs. In the KNIME labs, there are all the more, let's say, community-like, more advanced tools. The text processing is inside the KNIME labs, so you can open it and see what's available. There are also a number of other nodes. You know, you have the usual I/O, of course. You have the data manipulation part, the mining. Somebody was asking me about fuzzy stuff, and here you can see, you can find your fuzzy. Since KNIME now has more than 1,000 nodes, it has become complicated to find where all things are. So there is this search box here on top of the node repository. You see that? And for example, if you want to look for the fuzzy nodes, you type fuzzy, and then all the nodes with fuzzy in the name are going to appear. If I want to look, for example, for a stemmer, we were talking about stemming, so here it is. So this is the search box. It's very useful to find the node that you need. This is the editor where you build your workflow, okay? And I'm going to show how this one works. And so a workflow is a sequence of steps. Each step is implemented with a node. So each one of these blocks is called a node. And as you see, they follow each other. This one is a reader, so has only an output port, and all the other ones, they have input and output ports. You see here there is the little traffic light. I'm going very fast, so because I want to go to the text processing part very quickly. So please interrupt me if something is not clear or if you have questions, because otherwise I'm going to, go on. So here there is the little traffic light. The traffic light means the status, represents the status of the node. So there is the red traffic light is when a node has just been created and there is no information available to make it work. So to make it work, you need to configure it. So right click and then configure, okay? Or just double click, okay? To create a node, for example, let's take a node here from the file reader, okay? You just take the node from the node repository, drag and drop, and then you have your node there. If it's a particular reading node, then you just double click the data that you have available, right here, drag and drop the data, and you still get the file reader. So you drag and drop the node from the node repository into the workflow editor, or double click the node from the node repository, and it automatically goes into the workflow editor. Okay, let's remove some of these nodes. If you want, so when the node is created, it has a red traffic light. You need to configure it. So right click, configure, or double click, and again is the configuration window. Configuration settings, of course, depend on the task of the node. So if you have to do filtering, you have at least to give the pattern of the filtering you want to implement. If it's a file reader, you need to give the file path. So depending on the task of the node, you have to fill up some of the settings. In this case, it's just a path because it's a file reader. Now,
the way you think it should be. Okay, so now we have our data.
You can show the table with the data. The username, the review time.
Okay. So we've got all that stuff from the reviews. You've got the username, the title of the review, the text of the review, how many stars it got, the restaurant name, and as it turns out, the category. But again, that's what we're going to try and figure out on our own with our classification. But it's all in there. And these are all strings, by the way, in this table.
Did you have to write the parser in Java, or is there something that...
There is a node, so in the workflow 0, there is a node is called the HTTP retriever and HTML parser. They do that for you. And then there is a whole library in XML, the XML category that does this whole parsing for you. You need the Palladian extension though, so probably today with what I've told you to install, it's not going to work, but you need to download the Palladian extension. It's in the community other extension, and then it's working. Yeah, today, I didn't want to block everybody, if you're interested.
Okay, so at this point, we're good to go. We've got our table full of all our restaurant review data. And now we're going to do a very straightforward row filter. All this means is that there may be some rows in our table that we don't want. In our case, we're saying there's some rows that have a restaurant name that's missing, and we don't want those. We don't want those reviews in our final list. So to use a row filter, you first of all on the right-hand side, you see you have to set what are you looking at. So we're looking at the restaurant column. Anyway, looking at the restaurant column, and we're looking for missing values. Anything that matches that, we're good to go. And then we want to exclude those rows. So you can figure out your criteria, and then you can decide whether those rows should be included or excluded in your final data set. And then next up, as I said, those things are all strings, and we need to turn them into something called a document. The document is a way that, first of all, it groups all that information together in one object. And also, when you convert things to a document, you can then take advantage of all these processing things and filters in KNIME. So if your data comes out of your table reader and it's strings, then you need to go ahead and convert it to a document first, and then you're ready to go to process all that data. Now, we talked before about how you could right-click on the table reader and you could see everything you've got. Well, if you do that here, first I got to execute the node because it's yellow. And by the way, when you execute a node, if there are nodes before it that have not been executed yet, they will automatically execute any nodes previous in the workflow. Now if I go in here and I say, look at my table, you'll see we still have all those strings that were originally in our table, but now if you look at the document column, the only thing in there is is the beginning of the document, which happens to be the title of the review that the person gave. So if you want to see what's inside your document, you have to do one more step. And you can get something called the document viewer node. And you just hook that up by dragging the line, execute it, and now if I view that, now I can see all my document information that's in there. And you can double click on it and see all the details and go through them. So if you want to take a peek into what's in your document, that's how you can do it. It's not required for the workflow, but it's a way that you can look inside and see what's there. So actually that's the last part of the required workflow for our restaurant review, but I want to talk about some other things that you can do so that might help you for your own work. So if you look up here in the yellow box, those are the other readers. As we said before, you can do things like input a PDF file, a Microsoft Word file, XML, all those different things.
So you've got green lights on all those different boxes. It looks like you can go to the output of any of the boxes and inspect the output. Does that mean that your memory requirement has to be big enough to be able to hold the data at the output of every box at any given point in time? Or when I think about how much memory I need for a big data set, are there going to be multiple copies of it?
No, it's so. The way it works is that it loads its main memory as much as it can, but every node works by itself. It's a very, so it's relatively fast and relatively smart, so you don't need to load everything in memory. The only thing that you need to load in memory are, for some of the algorithms, because they work in block, then you need to load in memory the data, but only for some of the algorithms. So in general, you don't need to have a huge memory. Of course, if you have more memory, it's going to be faster, but you don't need, it's not going to crash if you don't have enough memory.
So there's a lot of different file types you can read in. And then down here, this blue block is talking about a bit of visualization. Again, we're not finished with our workflow yet, but we can still start doing some visualization of what we do have. So to set something up, like let's say we want to do a histogram, you start with your color manager, and this is just to say, how do I want the colors mapped? And so, for example, this has to do with the stars, the number of stars somebody gave in their review from 1 to 5. So we're going to say that the worst review, which is a 1, is going to be red, and that's going to have a gradient all the way to green for the best review, which is a 5. So we set that up and feed it into our histogram, and I'll execute this. And what you see here is on the left is our Chinese restaurant reviews, and on the right is the Italian. There's about 300 of each. And you can see the red band at the top is how many people gave 1-star reviews. The big green one at the bottom is 5-star. You'll notice Italian has a lot more 5-star reviews, interestingly. And the other thing you can do is that this is an interactive histogram. So if you click here on column and aggregation settings, you can change what's being represented here. For example, I might change this to reviews. And now, instead of looking at the stars between the two types of restaurants, this is saying for restaurants that have been reviewed between 0 and 60 times, this is what the star rating breaks down to. This is for restaurants that have been reviewed between 60 and 120 times, etc. So you can dynamically play around with the data right here and visualize different things. And then another one here is just a pie chart where I'll execute this. You saw this in an earlier slide, but all this is doing is breaking down the type of restaurant. And again, you can play with this dynamically. We change this to stars, and you can see that about 51% of the reviews rate the restaurants with a 5. Okay, so that's it for this first workflow 1, about reading the data. So we talked about pulling in the data from the table file that we generated with our web crawler in workflow 0. We filtered out a few rows that were not relevant to our classification, converted the strings to documents so we could do our processing. Oh, I didn't go over this, but at that point you had a table with all the original strings and the document column. We only need that document column because it's got everything we need. We don't need those original strings anymore. So the column filter will get rid of the columns you don't want. And then we talked about a few other formats that you can import. Okay, so just briefly, this is what workflow 0, the web crawler workflow, looks like. And if you do decide to run this later, as Rosaria said, you're going to need to download the Palladium extension from the KNIME community contributions. And if you do run this workflow, don't be alarmed that it might take a few hours because it is out there doing a web crawl, and that can take some time. So just keep that in mind. So the web crawler workflow has an HTML parser node. The XPath node is for XML parsing, and it has those things that you need in order to get the data you want. Okay, so next part of the workflow, enrichment. Now we want to actually do some tagging, start thinking about semantic information. So let's go back to the workflow. Okay. So we already did a few of this. You've seen the table reader, the row filter, the strings to document. We just talked about the column filter. And now we're going to get into this part here, enrichment, the parts of speech tagger. So at this point, if you want to do some tagging, there's a lot of different types of tagging you can do. In our case, we're choosing to do by parts of speech. So nouns, adjectives, adverbs, all those things. Now the KNIME node POS tagger has a built-in parts of speech tag set. And you can see on the right-hand column, it's called the Penn tree bank set. And there's a pointer to a website there that will tell you exactly how this breaks down. So you can go see how all the words, what all the codes are for this parts of speech tagging. But it's built into KNIME. You can choose other ways to do parts of speech tagging, but this is the one that is built in. And after you do your parts of speech tagging, you can do something called a bag of words. I'm going to execute this and show you what comes out of it. I'm going to right-click and do the output table. So what you have here is that, again, the document contains all the information from your review, the review title, the review text, the author, etc., although you can only see a little bit in this table. For every word in that document, it takes the word and shows you how it was tagged with the parts of speech. Now again, that website will tell you what all the codes mean, but for example, this first word, Italian, is tagged with JJ. JJ happens to be a code for a type of adjective. Then the word with is tagged with IN, that's a conjunction. Pizzazz is a noun, that's NN. So again, you can see how it all breaks down, but essentially what we've done now is you've taken every single word in the document and tagged it with a part of speech so that you can use that for classification.
When you say parts of speech, is that like audio processing, speech recognition, or?
No, it's only looking at the, yeah, it's just saying the word, you know, we know that the word Italian,
yeah.
We look it up, we know that it's an adjective.
It's grammar.
Yeah, oh, okay, probably.
Okay. Now that's it for our restaurant review workflow for this part, but I'm going to talk about some of the other types of tagging you can do. There's this one called the Stanford tagger, which is good for multilingual. You can do French, English, and German parts of speech. The Abner tagger is good for biomedical things, protein, cell line, cell type, DNA. The Oscar tagger is good if you're doing chemistry, chemical names. And then you get into things like the dictionary tagger. You can see there's a table that's being fed into this dictionary. So this is if you have your own set of words. For example, Rosaria was talking a little bit about sentiment analysis earlier. Let's say you want to know, when people write reviews, are these people happy? Are they mad? You know, are they saying positive things, negative things? There are some third-party sets you can get. For example, Stanford has a sentiment set you could get, and you could feed it into KNIME and use that to tag your reviews with positive words, for example. This table here is just a very simple, I'm going to execute it, a simple manual one, and it just contains a few positive words that you could feed in to your data set. There's also this one called the wildcard tagger, which is very similar, but as you can see, it's got two asterisks around the word good. So in addition to the word good, very good would fall in here, that kind of thing. So wildcard can expand your set a bit. But like I said, there are existing sets of tags that you can feed in, or you can create your own and use that to tag your data in the way that you want. Another example is this OpenNLP tagger, which somebody again came up with this set for recognizing people, locations, organizations, things like that. So it just depends on what domain your data is in. There's a lot of tagging that KNIME can help you with.
I can interrupt you. There was a question before. Sorry, somebody asked why is the name entity recognition so important? So depending on what you want to do with your project, usually you need to assign some particular value to each word. If you want to do sentiment analysis, you need to assign some sentiment to each word. If you want to do name recognition, then you need to, each word has its particular topic. In some problems, you don't need to do the named entity recognition like here, but depending on what you want to do, sometimes it might be helpful to have some tagging associated with each one of the words. It always depends on what you want to do, on the ontology that you want to define for the classification. Okay. Sorry.
Okay, so we talked about the parse-to-speech tagger. We talked about using bag of words to actually see how everything is tagged. Talked about a few of the other taggers that are available. The next step is pre-processing. Okay, so again, we've already gone over this initial part of the workflow, the table reader, the row filter, all the way through parts of speech tagger. Now we want to do a little filtering. So some of these are pretty straightforward. For example, the number filter, that just gets rid of numbers in your set of words. Punctuation strips all that out. Stop word filter. Stop words are words like that don't really contribute to your data classification, and you want to throw those out. There's a built-in list of stop words from KNIME, but you could create your own stop word filter as well. So now I'm conscious of my stop words as I'm talking. So the other things you can do, case converter, make everything lowercase because you don't want to differentiate between the word delicious with a capital D and the word delicious with a small d. Those are the same thing. So you want to make sure the case is matching. The snowball stemmer, we talked briefly about stemmers, but again, if you've got several words that have a different form but mean the same thing, like eating, eaten, eat, those all mean the same, you want to classify those the same. So the stemmer will chop off or group those correctly, so you only have one concept for eat and not three separate concepts. And the snowball stemmer, if you configure that, you'll notice that this one can do the stemming in 20 different languages. So that's handy. And then finally, we have here a parts of speech filter. So sometimes, people might be writing their reviews crazy words that are not very common, and the parts of speech tagger might not recognize every single word, so it might not have tagged every single word. So we're going to throw out any of those words that were not able to be tagged, as well as you can focus on the types of words that matter to you most in your classification. So again, these codes here, CC, CD, DT, you can look at that website that was mentioned earlier, and it will tell you what all these codes mean. But essentially what I'll say is the ones that are highlighted in blue are the ones we're going to use. The JJ ones, those are the adjectives. The NN ones are the types of nouns. And finally, we're going to look at the VBs, which are, you can guess, the verbs. So we're going to keep all those when we do our classification. Back to Rosaria for transformation.
So you want some time to try to reconfigure some of these nodes and explore some of the options. Okay. So now we are at the classification. So you see, you recognize this workflow. We have seen it. You know, that's what Cathy has been describing so far. The table reader, removing all the restaurants that don't have a name, transforming into a document. That's one of the most important nodes, because then allows you to apply all the other nodes and to apply the transformations onto the text. You can include a number of additional information with the document. So from the review title, to the review text, of course, then the authors, and a number of other things that can be included in the document. We also included the category. You remember the category was Italian or Chinese, and that was our original problem. Our original classification problem is that I have the review and I want to know if the guy is talking about a Chinese or about an Italian restaurant. The category that comes from TripAdvisor is the class that I'm going to use for my classification algorithm, and it's in here. Okay, remember that. This is the name of the restaurant, and then everything else is not so important. Okay, so in the document we have everything. We have the text, we have the title, we have the author, we have the restaurant name, and we have the category. That is the thing that we want to be able to classify. She has shown already the part of speech tagger, okay, and this one, assigns grammar tags to each word. We got rid of a number of let's say, useless words, the numbers, all the punctuations, okay, all the stop word filter, so all the stop words, all the words that according to this built-in list are supposedly they don't carry any information. We converted everything to lowercase, and then finally we used the stemming. The stemming was, as I described before, to remove all these changes in the original stem of the word and keep everything, put everything into only one stem. If I show you, for example, let's see what I find. The output of the snowball stemmer, you don't see anything because everything is contained inside the document. If you want to see the effect of the snowball stemmer, you remember what you have to do, right? She showed that at the beginning you have to use the document viewer. That's because you have to see all the details of the document. Okay. So then finally you move to the bag of word creator. The bag of word creator, we have seen it already. That's a node that extracts all the words in a document. Okay? So let's see how it works. So let's see how the configuration window works. So it takes the document and it just extracts the list of words. So let's see what the output is. Okay. Those are all the words with their tagging. And as you see, you have Italian, which is an adjective, and let's see what I find. So you have the waiter, and all these words are here. You have the inspire, that probably is the verb, or it's inspiration. So they have been reduced to their original stem. So you have inspire for both the verb and the stem. So that's what the bag of words does. You have a list of words, and those are the words contained in a particular document. So in this case, we have this document with title Italian pizza, and those are all the words contained in this document. Here we have another document with title Italian, and those are all the words contained in this other document. Okay, so I have a list of words, but how can I apply any classification algorithm to a list of words, really, right? I need numbers. Okay. Sorry. So to calculate numbers, you can do in many different ways. One of the possible ways is to calculate the frequency of a word. So the TF node is the one that calculates the frequency. There are many types of frequencies, not the only possible. Counting the number of words in a document is not the only possible frequency that you can have. Counting the number of words, for example, let's say the number of the word food. The word food is mentioned 3 times in the text. 3 is the absolute frequency of the word food. However, if the text is very long, being mentioned 3 times, or if the text is very short, being still mentioned 3 times has a very different meaning, right? Because I say 5 words, and 3 words of those 5 words is food. Obviously, food is very important. If I say 200,000 words and only 3 words are, food, then obviously that's not very important. So you can calculate. You can use the absolute frequency, or you can use then the relative frequency. But those are not the only frequency available. So if I move into my where is it? KNIME Labs, and then text processing. Then there is a full subcategory frequencies, and those are all the possible frequencies that you might want to use. Absolute and relative frequencies are the most common, but for example, there is also the inverse document frequency. The inverse document frequency counts how many words, how many times the word food is available in the different documents divided by the number of documents that you have. So basically, if a word happens often in a document, but it happens often in all the documents, like food probably in this case, which is important for both Chinese and Italian restaurant, then the word is not so important, because it's important for all possible documents. However, if I have the word, let's say, pizza, which is, thank you, because I'm having a crisis. However, if I have the word pizza, and the word pizza happens only in some of the documents, but still enough times to be an important word, then it's actually a word that tells me something about the document, right? So the inverse document frequency tells me that a word has to be frequent in a document, but has to be also not that much frequent in all possible documents, to be meaningful. Okay, so when I calculate, let's say in this case we use the relative frequency, and if I inspect the output value, the output data table of the TF node, I can see that for each term, in each document, I have the number, in this case, the relative frequency of how many times this word happens in that document. At this point, I have a number, and once I have numbers, I can deal with text like I can deal with numbers. So I can use the traditional classification techniques. To transform the list of words into a vector of words, then we use the document vector. Okay, so the document vector takes the document and takes all the words that are in these documents and transform them into a matrix. I can show you much quickly. It's easier to show it than to describe it. So as you see, here you have the document. That's the document with title Dim Sum No More, which obviously sounds like not a good review. And here you have all the words that are available in that particular document. So, for example, you have the word dim that happens once, Zam that happens once, wife, city, view, and so on. So those are all the words that are available in this particular document. Let's take this one, for example, 3 dishes, 3 times perfect. Dim and Zam is not there, but the wife is there. So, it's numerization, a discretization of the text, and so on. So basically, at the end, you have a matrix representation of the words that are in the document. In this particular case, with the document vector, we use the bit vector. The bit vector is the 0, 1 representation. So the word is either there or not there. The word is either there or not there. Of course, you can be a bit more specific, and you know, you can have you can use, instead of the 0, 1 representation, you can use the relative frequency that you have calculated before. So in this case, you have to remove the bit vector, and then if you have a measure that expresses frequencies, you have to tell which measure you want to use. So the reason why, I don't know, I've always wondered about that. Why do I have to use a 0, 1 representation which tells me less than a frequency representation, right? The frequency representation has much more information than just a 0, 1 representation. Well, so some time ago I had a project, and as I said before, the problem in a lot of the text processing tasks is that you are supposed to define a class system. So in this case, we had Italian and Chinese because we built this example on purpose to do the tutorial. But you know, in a lot of cases, you don't have these classes available. You have text, and you don't know what, you know, which kind of class they refer to. So usually, at least for me, that works for me, you have to become creative. If you don't want to manually label any text, you know, any document that it's in your collection, and which might take a long time, then you need to be creative and somehow to extrapolate an ontology that is already available in another data set, extrapolate it for your data set as well. Since sometimes the ontologies, I mean, the ontology that you borrow from another data set might not be fitting 100% your problem, then using a 0, 1 representation, you know, puts you a bit on the safer side if you are not completely sure that your classification system, your ontology works. Okay, so going back to our document representation, we have this 0, 1 representation. This one is still a dim, but not a sum, obviously. You know, this one is a must visit in North Beach. And this one is a restaurant, and there are a few other words. Visit is a visit to the restaurant, and the food, and so on. So this is our representation. However, if we scroll the whole matrix, there is no trace of the category. You remember the category contained the class of the restaurant, so Italian or Chinese. So there is no trace of that. So to do that, we use the document data extractor, and this document data extractor allows you to extract features that you have put before into the document using the string to document node. In this case, we want to extract the category because that's the one where we want to perform the classification on. The final data table is again the 0, 1 representation of our document, okay? But then at the end, I have the category which tell me if the restaurant is Chinese or Italian, okay? At this point, I have a classical classification problem. I have numbers, I have a vector of numbers for each record, and I have a class that I'm supposed to predict. So that's nothing different from the usual classification problem. So in this particular case, then I use the partitioning node to, you know, to prepare my training set and my test set. I use 90%, no, 80% of my data to build the training set, and the remaining 20% to build the test set. This is the partitioning node. That's what it does. It divides data. And then I use the decision tree learner. The decision tree learner builds a decision tree based on the training set, and those are all the parameters, the settings that fit the decision tree. The class for the decision tree, for the training of the decision tree, is the category. You remember, it's the one that we extracted from the document, Chinese or Italian. Then we use the entropy measure. There is pruning or non-pruning, and you know, all the settings that you use for the decision tree. So let's have a look at the output of the decision tree now. some of these nodes, we have shown so far that there is the data table. So right click, last option, and the last option is always the data table. Some of these nodes, they also have a view. The view allows you for a bit more interactivity instead of just inspecting the data. The decision tree has also a view. So right click and select, for example, view decision tree view. Okay, so this is our decision tree. Not today with this. So we start with a data set which has 49.5% Chinese restaurants and 50.5% Italian restaurants. The first discriminant word is Italian, which makes sense. Yeah, we have discovered that Italian means Italian. Yeah. So if Italian is there, then it's an Italian restaurant. If it's not there, then let's see what the second discriminative word is. The second discriminative word is pizza, which also makes sense, even though it's not like my pizza. And so if the word pizza is there, it's probably an Italian restaurant. If the word pizza is not there, let's have a look at the third discriminative word. The third discriminative word is some, so that's probably a Chinese restaurant. Here you have the representation of the class distribution for the data set, for the data group covered by this node of the decision tree. So we start from a 50-50 distribution at the beginning, then we move, this node covers only Italian restaurants, okay, and this one still has a distribution, Chinese to Italian. It's a bit bigger than, so more than 50-50, so it's more Chinese than Italian restaurants. If there is pizza, we also end up in a full Italian restaurant distribution, and so on. And here we can see we are at the word some, and the word some identifies only Chinese restaurant, and so on. So continuing reading the decision tree, then you can see the next discriminative word is Chinese, then pasta, Chinatown, China, wine, moose. And then beach. Beach is probably for North Beach, since those are reviews from restaurants in San Francisco. I assume that since beach is related to Italian, those are restaurants in North Beach. So, and so on. Of course, the deeper we go into the decision tree, the less meaningful the words are, because they identify only a few of the text, of the documents that are available. So only 2 or 3 documents are going to be identified, for example, by V, which I have no idea what it means. Something like that. So this is our the decision tree that we get at the end. Yeah, we can. So after we have trained our decision tree, we can apply the decision tree predictor to the test set. Here we had the training set, 80% of the data, and here the test set, 20% of the data. And if we run the decision tree predictor, we apply the model, and then we can see that this one is the original class, and this one is the prediction by the decision tree. And you can see that sometimes it's not completely correct. If we want to estimate the accuracy of this model, we use the scorer node, and then we check the accuracy. Let's use the view, which is nicer. And you can see here the confusion matrix of our little classification problem, and you can find the accuracy, which is 89%. So I mean, that was an easy problem, of course, with a very high accuracy, but still, it's an interesting example. So now we use the decision tree. The decision tree, everybody can say that the training set is too small, so we get a 90% accuracy, but we are probably very lucky, and so the usual complaining that there is when you apply a data mining model. So the part below uses a cross validation. When the data set is not too big, then to avoid ending up in a division between training set and test set that is too lucky or too unlucky, then you use the cross validation. You make this separation 10, 20 times, and you hope that you average out this lucky or unlucky effect, right? So this is the cross validation loop. This is the cross partitioner, which works like the partitioning node, only that it performs the 80% random separation between training set and test set 10 times. So in this case, this training set 80% and 20% test set the first time, then another round of creation of training set and test set, building the decision tree on the training set, evaluating the decision tree on the test set, and then calculating the statistics of this decision tree training the 10 times. Okay, so I just wanted to show you. And then eventually you have the statistics table is going to show you the average value of the error, which is in this case 12%, so we have an accuracy in average which is 88%, which is a bit lower from what we had before. The problem, so the training set was very small, but the problem was very easy, so at the end it was okay. It was in the limit of the acceptable range for our problem. Okay, so there are 3 more workflows. Let's see if I forgot something. Okay, so there are 3 more workflows. One is about multi-word. For example, you remember the case of dim-sum. Dim-sum is actually only one word, only that so it's 2 words, but it's only one concept, right? So it doesn't make sense to use dim-sum as dim and sum. Probably would have been nicer to have them together. So there are a few. There is a node that allows you to create n-grams. N-grams is words that happen often together, like probably dim-sum or North Beach, right? So in this case, you create a 2 grams, for example, and this 2 grams is going to collect a few words that happen very often together. So classification using multi-words. Now for this data set, I'm not sure it's going to make a lot of difference because it's an easy one. But using multi-words, if there are so tagging the multi-words, if there are any in the document, it might help with the final representation of the text and then the final classification. Another workflow that you have, you might have downloaded is the clustering of the documents. So sometimes in this case we knew which one was Italian and which one was Chinese because we downloaded them like that. So we did this exercise, but very often you have no idea what each document means. So what you might want to do is instead of doing a supervised classification, you just run a clustering and you hope that similar things end up together and they mean something. So that's another example. And in this case, it uses hierarchical clustering. You can use k-means, you can use the nearest neighbors, whatever algorithm for clustering you want to use. And then finally, there is the topic extraction. That's a new node that uses the parallel linear discriminant analysis and extracts the most important keywords. You remember we extracted only the bag of words, but there are a few. The bag of words includes all possible words in the document. If you have a long document, it's not really feasible, right? So there are a few nodes like the topic extractor or like the key graph keywords extractor. They extract only the most significant keywords of the document. So if you have very large documents, not like our reviews in this case, but if you have very large documents, then it might be useful, to extract only the most meaningful words, keywords for each section. Okay, so I'm going to quickly show them, but then I'm not going to talk much because otherwise I think I'm going to overflow. So this one performs the same classification that we did before, but using the n-gram nodes. You remember the n-gram nodes here, they define, they create a set of words like 2 grams or 3 grams, a set of words that often happen together. So dim-sum was one, North Beach was another one. So that's the node, and here you can specify how long you want your sequence of words to be, how many words you want to include in your sequence. Usually it helps, it depends on the text of course, but usually it helps because there are a combination of words that happen often together. Then there is this other workflow, is about clustering. The pre-processing is very much the same. You remember, reading, filtering what's not available, transforming into a document, applying a number of transformation to the document. So in this case, tagging, using the part of speech tagger, filtering out all the numbers, the punctuation, the stop words, moving everything to lowercase. You remember this, we have done it before. So it's the same processing, because at the end I want to move to a data matrix. I want to move to a data table. Converting the word to its stem, filtering out some useless grammar words, creating a bag of words, calculating a few frequencies. In this case, there is also the inverse category frequency. It's a subspecies of the frequency. And then finally transforming into the document vector. The only difference here comes after we have created this document matrix. After this document matrix, what we don't have the decision tree anymore, because we don't want to do a supervised classification, but we have this hierarchical clustering node, because we want to apply clustering. So that's the only difference. But as you see, up to here, the whole processing is the same. And then finally, we have the topic extraction, and this is the node that performs the topic extraction. If you select the node, you are going to have all the information where the algorithm for the topic extraction is coming. It's a complex algorithm. And then you can read all the details if you are interested in them here. So that's another node that is important. Yeah. Okay, so I think I'm done with what I wanted to say. If I'm going to put back the slide with the code for the book, if you want to. If you have any questions, if you want to ask me some more, if we want to do the, we want to read your own file, if you want to read a PDF file or a Word file, an HTML file, then we can start to work on that. Yeah.
Can I cover the Twitter?
Okay. Yeah, that's a good point. So one of the things that you can also do, we have some nodes that connect to Twitter and to Google API, and you can download the tweets.
I have a question. Let me use KNIME, but I'm wondering, so this is very nice to set up a project and define the workflow and everything, but when you want to put this into production, what do you do to run this, in a batch process on a server?
KNIME can run in batch. You can write a batch command. So KNIME is open source. Everybody always asks me today about it, but I will ask it myself. How do you make money? How do you pay the salaries if KNIME is open source? So around KNIME, so the whole analytical platform is free. So all of them, there is no minor version, bigger version, no. But the only thing is that if you, there are a few products that allow you to do productization a bit easier. So if you want, you can extract your own batch command and run it and include it in your, whatever it is that you're using in your tool. That's possible. I've done that, but it's complicated, because also for the error inspection and the whole thing. Otherwise, there are solutions that you can buy for enterprise, like not for your personal usage, but for enterprise.
Out of your experience, does this scale? So if you run this on, hundreds of thousands of documents?
Hundreds of thousands is not a problem. Yeah, I've done it on millions. Well, it depends on the text. It becomes slower. I mean, I've done it on millions on my machine. It does become slower, definitely. But, after a few millions. Yeah?
It does connect to a database, right?
Sorry?
KNIME does connect to a database.
Yeah, there is a database category below the database nodes. Yeah, also connecting to Hadoop Hive is possible.
Also, what are the other solutions in the market regarding the same? So I think the Tyco is what I've heard. Is it similar thing or different? What are the other solutions in the market basically? Who does the workflow thing?
The solution the other solutions, the competition.
Similar solutions.
You mean from other products or from
other products?
You want me? I don't know. You know, I'm not the right person to ask that to. But there are a few, I don't know, SAS does that for sure. R has something similar. I'm not an expert of this, so yeah. Yeah, R has that for sure. I use it a bit, but because I don't use R much for text processing. I use R more for the graphical stuff. So, yeah.
Is it possible parsing to take control of how the text word boundaries, for example, the division between an apostrophe and a C flow?
I think it's possible. Yeah, you can define the level of the parsing. Yes. Also from the comma, you know, level and all those things, the apostrophe, you can define that. Yeah. Yeah. More questions? Yeah.
Maybe this will be discussed, but when you have a stream of input data, not just a file or a batch of files, but a constant stream of data, how do you continually process that, continually update your results?
Yeah, this is, yeah, so there are some loops. So what I've seen doing, there is not a dedicated solution for that, but what I've seen doing, there are some loops, and there is one special loop is called loop with a condition, the final condition, something like that, and this one keeps streaming until it's finished. Yeah, so you can use this one. There are, yeah, for example, for the Twitter node that she's going to show now, you know, it keeps going until there is nothing else coming in.
Yeah, so just briefly on this Twitter node, so this is a new thing with KNIME, so you can actually extract data directly from the Twitter stream. And just briefly for people who aren't familiar with the Twitter stream, Twitter offers its stream free to anyone, not just through KNIME, but through other methodologies. However, the Twitter stream that you get access to, this public stream, is really only a small subset of the whole fire hose. So just if you, any way that you access this stream, you're going to be getting a smaller percentage. There are paid ways and third parties where you can access more Twitter data, but if you use the free stuff, you're just going to get a smaller set. But that being said, that's still quite a bit of data. And just if you wanted to use it in KNIME, essentially there's some instructions over here, but you need to set up a free developer account with Twitter, and you have to register your application. When you do that, you're given some credentials. And when you try and configure this node, this is where you'll enter your credentials for your account that you've created. And once you've got that set up, you can get it running. And there's a couple of different ways to look at the Twitter stream, but this one is looking in the past. So it'll look over, say, the past week or so of tweets in the public stream and extract that percentage that you can get. And once you've got that, you can then run it through a search to look for whatever you want to look for in that data. So it's just another nice way to pull data automatically into KNIME for analysis.
When you've called up the icons, it seems that there's always a tab of flow variables. What are the flow variables exactly? How do you work those?
Shall I answer this one? Shall I answer that? So the flow variable is, I've shown you a workflow. That's a bit an advanced concept. So I've shown you a workflow, but for example, let's say you have a problem and you want to filter out all the people who were born in the United States, okay? But today, United States today, tomorrow you want to filter out all the people who were born, I don't know, in Mexico, right? So the native country, the country where people come from, has to become a parameter. The flow variable are these parameters. So they allow you to override some settings in some nodes, and you can change the value of this setting overriding using the flow variable.
So what's the best way to get more detailed documentation of what's happening, particularly in some of the more complex blocks? Because the help file looks like it's a good, fairly superficial description, but some of these blocks are doing fairly complicated algorithms.
Some of them, yeah. So there are these two books. I would say the two books. Otherwise, yeah, probably the two books if you want something a bit more, complete. This one that I gave you for free today, the first one, that's the basic one, and then there is the advanced one, is the cookbook. So the second one I can't give you for free because I'm not the only author. So. Yeah, otherwise, yeah. Otherwise there are the courses. We do courses around. Now in San Francisco we have just done one in June, so I'm not sure we are going to repeat it often. But we do one-day courses. The next one I think we do in Toronto. So, yeah.
I have a question towards, to refocus back on towards streaming API. There's a lot of different other frameworks out there for streaming, Samza, Spark, Storm. Is that part of the pipeline, or you're probably going to focus on file-based?
So some of these nodes there are some dedicated nodes for these kind of things. So for example, as I said, there are database nodes, so from Hadoop, Hive, and they exist already. If they don't exist yet, there are some nodes like REST service node or web services node, or you can connect to anything, and whatever they. So for example, the Google API, I use the REST service node, and I don't necessarily use the Google API dedicated node.
Okay, so that's part of your polling.
Yeah.
So if it's something that's more proprietary, that doesn't have that does not currently have a REST endpoint, that's probably not supported at this time.
No, there is another node. It's the external tool node. You can call anything from there as long as it's an executable. You can call anything. So a colleague of mine was running SAS from inside KNIME to run some SAS scripts. So I mean, yeah. Of course, if it's dedicated, it's easier because then you have exactly those parameters.
Yeah.
But you can do it also with the external tool node or the web service node or the REST service node, depending on the structure. Yeah. Or somebody has already developed. This is what usually happens. Yeah.
Is there a size limitation?
For what?
Input, like if you had to ingest how many a second?
So I've run, the last project I've run had 200 million rows. I mean, it's on my laptop. It doesn't break. Of course, it was not super fast, but it doesn't break. So now with these Hadoop Hive nodes and Cloudera nodes and Impala nodes, so all these nodes, you can access stuff much faster. So actually, my next project is to transform this thing that took 2 days to transform it and use especially the first part to move it into Hadoop Hive. Yeah, cool. And use the statement there. Yeah. I mean, in theory, all it's possible because then it's very versatile.
Just bits.
Yeah, you have to exactly know what to do if there is no dedicated. Yeah?
Have you tried running KNIME with real-time frameworks like Spark or Storm or something like that?
Yeah, no, I haven't. I personally haven't. I know that they want to do it, but I don't know how to do that. So there is, I know I've seen somebody who has done it with this loop with the condition at the end, and this one basically loops until you get something. Yeah, but I haven't done it, so I don't know. But I'm going to do it. That's part of my next challenge. Yeah.
Yeah, kind of follow up this question. If you process each individual nodes, you keep the individual results, so it's sort of
you can
take a lot of space.
No, it doesn't. No, actually not. No, it's so it doesn't load in memory what has already been executed.
Oh.
So if it's already been executed, it's not in memory anymore. It gets saved to disk. So when I save the workflow that I had there, all the executed nodes are going to be saved with their status, their configuration, and the data in input and output.
Oh.
So all this stuff, but it's not that big actually.
Yeah.
I mean, it's how to say, not zipped, anyway.
Okay.
And it doesn't take too much space. The memory is also it's not a big problem. As I said, I run it with 200 million rows. I mean, it's low, but it's okay. Doesn't take it.
It processes one document, looks like serially, but is there a way to process?
They do, no, it processes everything together. That's why you have the data table.
Oh.
Yeah.
So after each document, you put data table and then process it yourself.
No, so it has the data table. Yeah, now about the text processing, I don't know. I know for the numbers, the data table is processed all together. So it doesn't go, it doesn't loop.
I think I have the same question. So I guess it depends on the type of processing.
Yeah.
Some processing may need to see the beginning and end.
This
of
is
data,
true. This is true. Yeah.
And some processing, the first row can move on to the next node.
This is true. Yeah, so for example, the decision tree needed to see all the data at the beginning and at the end, and until the version, the 2.8, there was a problem with memory, with the decision tree. Now they fixed it, I don't know how they did it, but now they fixed it. So there is some clever thing, I don't know. So now I don't know how they did it actually exactly, but yeah, it's true. So some nodes, they do need to see everything. So when it's possible, they do it, as a stream. When it's not possible, they don't do it. But there are less and less nodes now that there are memory problems. I remember the decision tree until the 2.8. I don't know how much now. Yeah.
In the decisions tree that you showed, right? The decision tree was created automatically from the data, or did you put the words?
No, automatically. Yeah. There was the decision tree with the C4.5.
So there are nodes there, and there's that background. Is that just labeling?
This is just labeling the background. I didn't show how to do it, but it's an annotation. You can right click anywhere, and then you get a label, and then you can color it and make. I like to do it because then it's easier to understand. I use my workflow, since it's graphical, I use my workflow also for documentation. So, and then I write everything in there. Actually, I made a video only, so without PowerPoint. I put the title, and then I was zooming on the different annotations, so to explaining the different pieces, which were fantastically. Everybody's asking me which software I used. Yeah?
Yeah, another thing is, we basically create a document, right? From string to document.
Yeah.
So
We basically, sorry.
So all the strings, you take all the strings and convert to a document. What's the document? Data frame or?
The document is, I don't know what it's used, which kind of structure is used underneath.
How is it stored?
Which is what? Which one?
It's stored.
How is it stored?
Yeah.
I don't know. It's I don't know which. I can ask Kilian which kind of structure you use for the document.
Can you add fields in that document?
Fields?
Can you?
Some more. No, it's fixed. The structure there is fixed.
So maybe create a different node.
Yeah, sure. You can expand it. Yeah, sure. Or you can, yeah.
Can you show the what kind of multi-class errors it can handle?
What kind of what?
Multi-class. It means
multi-class.
you have different classifications.
You mean the confusion matrix?
Yeah. No, not the confusion matrix, but if you have like to categorize into 6 or 7 different classes.
Well, I'll show you the scorer nodes that are available. We go to the mining, and there is the scoring. So those are the nodes that are available for scoring. Usually, so the scorer and the numeric scorer, they use only a 2 class with the confusion matrix.
Yeah.
I don't think there is one that uses the multi-class, all of them, because also the entropy scorer uses a 2 class. I can ask them if they can expand it and make a multi-class scorer. That's actually should be easy. Yeah. I force them to do stuff.